Hi, my name is Tianle Liu, and I'm here to do the probability homework for problem one. And here is the way to do it. You can see the shared screen on my monitor. And now let's do it step by step. Uh, we already get the y equals to gx on the problem, and I paste a picture from the clues of the homework given by professor. And now we can use this picture and to find out how to draw this and how to find the uh, probability density function and the probability function of the y with respective to y. So now for the first one, we need to see what is the domain of the so how to cut the domain for the y of the probability function and the its density function. We already get the y with respective to x, and now we only need to transfer it to see what is the range of the y. So for the first one, we get the when x is less than 0, we have the y equals to 2. So for especially we already get the y equals to 2. And also we get y equals to 0 for the range of the x from 0 to 1. And also we get the since it's from 1 to y for the x, we already get the function of the minus x plus 1, which is 1 minus x. So we get its y from, I believe it's negative 1 to 0. To 0. Yeah. And for the last one, for x larger than 2, we will get y equals to negative 1. Okay, so this will be the range for the probability function of the y. So we can solve it one by one. Let's number it. For the first one, for the y equals to 2, what is the probability function? Probability of y equals to 2, we can get the probability of x less than 0, right? So by the definition, probability of the probability function of the x less than something will equals to the density function of the x. So we can get the function of the fx 0 for this one. But this should add one impulse function after this to get the correct answer because it's transferred to the to represent the step of this point. So we will get the have to multiply it by the sigma. Since y equals to 2, we need to use the y minus 2 to represent it. So we already get this one, which is the fx 0 multiplied by sigma y minus 2. For the second one, we will test the y equals to 0. For the probability of y equals to 0, we will get probability of x larger than 0 and less than y, right? For this one, we only need to set the upper bound of the 1 and the lower bound as x. Then we get this one. But also we have to imply it to a impulse function because we need to use the impulse function to see what's the step length of this one. So for this one, we will have the y equals to 0. So nothing difficult. We will get the multiply it by the sigma of the y equals to 0, which is don't need to add any plus or minus. The third one, we have the y larger than -1 and less than 0. So for this one, it's kind of special. We need to use one definition function, which is the probability function of the y will equals to probability of function of x, and divided by the derivative of the gx with absolute bar. And the derivative of gx for this one will be the -1, because we have the minus x plus 1, which is -1 in the absolute bar. And the fx will be uh, fx will be the fx. Since for this problem we have to find it in terms of the x, the probability function of the x and the density function of x. So we can just use the fx, but we have to transfer it, transfer the x with respect to the y. So we will get the x equals to let me check. Which is y minus, yeah, s should be the 1 minus y, and it will be equals to 1 minus y. Okay, that's it for the problem. For the part 3, let's do it in by the part 2 first. For the part 4, it's kind of similar. We only need to y equals to -1 with the probability of y equals to 1 equals to the probability of s larger than 2, which is the 1 minus probability of, excuse me, 1 x less or equal to, oh, sorry, 2, which is 1 minus fx2. Yeah, so we solved all for the probability function for the y. Oh, wait, we forgot this one. For this one, we also need to add one sigma function, impulse function, to represent the step. So we need to have y equals to -1, so we will have y plus 1. So that's all for the fy, the probability function. Right? So we can compare it to the graph. We can see that there are 3 possible impulse function in this step, in the separate function. So we see the -1 we have 1, for the 0 we have 1, for the 2 we have 1, and it represents the the function respectively. And also we have a part of the fx, which is this one, right? So that's solved for the problem here. And also we need to find the density function. Usually the density function should be defined by the integral. But for this one, is we don't need to do that complicated, I think. For this one, we need to we need to cut it for the range. Obviously, for this one, we will have y less than -1 will equals to 0, y larger than 2 will equals to 1. Because we can see from the probability function, we don't have anything to do out of this range. So for the out of range part, will equals to 0, and for the upper out of the upper bound, we will equals to 1. And we only need to see how to cut it through from the two different range. In this case, based on this one, we can see that the change of this one will from the -1 to 1, -1 to 0, and 0 to 2, right? We can come through the easiest one, because from the probability function, we know that when y equals to 2, there's a step function. There's an impulse function that will jump it to with the value of the density x of the 0, which means it's only just like a small jump of the graph. So for this one, we will get this 1 minus density function of x equals to 0 directly, because the impulse function is just a instant jump, not the continuing process. But for the -1 to 0 of the y range, it's kind of complicated. We need to find it out by the fy, density function y, equals to what? By the definition, it's equals to probability of the y less than the y, right? And by the gx of that part, we can get the y equals to 1 minus x less than y, which will turns it into probability of x larger than 1 minus y, right? And it will turns into 1 minus probability of x less than or equal to 1 minus y, because this is what we want. We want it to be represented by the density function of x. So turns into this part. By the definition, we can get the 1 minus density function of y minus 1. Thus, we get all part of the density function here. And we can see that we can see from this one, from this picture, we can see it starts at the 1 minus fx 1 minus 1 to the 1 minus fx1, because it's from the -1 to 0. And this is part of the function. And also for this one, we can see that it's only one impulse function for the fx density function of the 0. So it's an instant jump at the y equals to 2. In this case, we can get this one. Thus, it's all solved for the probability function and the density function. And that's it for this problem. Thank you.